All right, folks, in this video here, we're going to talk about fractional expressions. Let's take a look at examples on 68A. First of all, we have 1 over x plus 7, x minus 7, and x minus 1, x plus 1. Immediately in your mind, you should be thinking about difference of a square because these are fractions, so that's why we need to find out, okay, what is the best combination for us so that we can create a difference of a square combination. So for example, what I mean by that is instead of finding all the common denominator between x plus 7, x minus 1, x minus 7, x plus 1, we actually group them up as x plus 7, x minus 7, then x minus 1, x plus 1. So for the first one, we did this. So pretty straightforward. On the top, it's just 1, right? So which can put x minus 7 on the top. And on the top was 1 as well. So we put x plus 1 and x minus 1 here. After simplification, we have 2x. The 2x come from the x minus 7 plus x plus 7. And also the 2x come from the x plus 1 plus x minus 1. And on the bottom, right, this is where things get a little bit more interesting since we have the same numerator. And then for us, we just have to find the common denominator for everything over here. So for the first term, we need to multiply the x minus 1 and x plus 1. And for the second term, we need to multiply the x plus 7 and x minus 7, right? So after that, we'll be able to get something that looks like that. And we already know that the x minus 1 times x plus 1 is going to be x squared minus 1. Also, we know that x squared minus x plus 7 times x minus 7 will be x squared minus 49. After that, we'll be able to get 2x times x squared minus 1 plus 49. Right? So plus minus, okay, all good. So this is done. And also this one will be plus 48. So once we open this up, there will be 96x. So that's how we get 96x on the top. And then we have the bottom as x plus 7 times x minus 7 times x minus 1 times x plus 1. So some of you guys might ask, Tony, do I have to expand the denominator? It does not have to. The reason why, since the example already tell you that you can do this, no problem, you're gonna keep it that way. Even if I need to do that, it's just gonna be that times x squared minus 1, right? So, and we keep it simple like that. And if you wanna expand it, again, you can expand it. But in this case, since the example is asking us to do that, we're just gonna keep it that way, okay? So let's move on to question number 1, okay? So I'm gonna pause the video for a little bit. I'm gonna get you guys to try by yourself first. Okay, so we have x minus 3. We also have x plus 3. So we're gonna group them together. We also is going to group that together as well. So after that, you should be getting x minus 3, x plus 3, on the top x plus 3, minus x minus 3. Okay, so this is done for the first two fractions. And then we have x minus 1, x plus 1, and then x plus 1 plus, oh, since this is minus and we have everything grouped on the top, so it's going to be x plus 1 minus x minus 1. And then remember, there's a negative over here. So even though there is a positive here, so if we're grouping up together, so this will be a negative. So after that, you'll be able to get 6 on the top, yada, yada, yada. And also we will have 2 on the top, yada, yada, yada. So I just, I'll just put a short form for that, okay? So you will follow the exact same thing as you did over here and here, and you'll be able to get your answers, okay? So the answer at the end, the numerator should be, you should be getting 4x squared plus 12. All right, pretty straightforward. All right, let's move on to page B. Let's just take a look at page B here. Okay, 1 second, we'll do page B. Where's page B? B. All right, here we go. Okay, so, all right, page B, some of you guys were asking about this question, like how do we do this particular question? So first of all, you already know that we can group them up together. That's gonna be the easy part over here. So you would see that once we are doing, we did this, and you will be able to get a squared minus 1. So that actually can combine with the a squared plus 1 over here. So that's what makes life a little bit easier for us. So with that being said, let's, again, pause the video for a little bit. I want you guys to try it out. And after you guys are done, you can resume the video. Okay, so first, we'll find the LCM for a minus 1 and a plus 1. This will be a minus 1, a plus 1, and on the top it will be a plus 1 minus a minus 1. Okay, the next will be same thing here, and also same thing here. All right, so once that's done, on the top of the first one, you will have 2 over a squared minus 1 minus a squared plus 1, oh, and minus 4, a to the power of 4 plus 1. So over here, this will be, on the bottom, a squared minus 1, a squared plus 1, and then 2a squared plus 1 minus 2a squared minus 1 minus a to the power of 4 plus 1 over 4. So now you can see that the bottom will be a to the power of 4 minus 1, right? So perfect. A to the power of 4 plus 1. This is 4 as well. So on the top, you will be getting 4. All right, so if you multiply it back in, and after simplification, you will get 4. So last but not least, again, this is very, very simple. You'll be able to get a to the power of 4 minus 1, a to the power of 4 plus 1, and then on the top will be 4a to the power of 4 minus 1 plus 1 minus 4a to the power of 4 minus 1. Okay, when you simplify it, it will be 8 on the top, and then a to the power of 4 minus 1 and a to the power of 4 plus 1. You can also rewrite this as 8 over a to the power of 8 minus 1. Okay, so that's 68b. Let's move on to 68 and 68(9). So this is also a fraction expression. Let's say based on the example over here, we have 3 over 5 over 6. So pretty easy, right? So you're just doing fraction. You're just doing the convert it. So over here you have 3 over 4 times 1 over 9, basically. So 1, 3, you have 1 over 12. This is more like level E stuff. All right, so again, so this one you have 3 divided by 5 over 6. So basically it's 3 multiplied by 6 over 5. You got 18 on the top, 5 on the bottom. So you have 3 over 5. Or you can leave it as 18 over 5. Doesn't matter. All right, let's take a look at the algebra expression over here. So the algebra expression looks a little bit more complicated. Again, what you need to do is understanding what the example is trying to tell me. So the example here is telling me that, okay, on the top we have 1 plus 1 over a. So what I want to do over here is that we want to find a. I want to represent the 1 as a over a plus 1 over a. It will be a plus 1 over a. That gives you the perfect version of that. Same thing over here. This is a over a minus 1 over a. So this will be a minus 1 over a. So then you will be getting a plus 1 times a over a minus 1. So you reduce the reduce the a. You get a plus 1 and a minus 1. Okay, pretty simple, right? So let's try question number 4. So in this case, on the top, I know that this is x over x. So there will be x plus 1 over x times 1 over x plus 1. There we go. The answer will be 1 over x. Pretty straightforward. Okay, so 69b. All right, let's take a look at 69b over here. Let's try question number 8. So for question number 8, pretty straightforward thing for us to do. Let's see what we can do over here. So what I want you to do is I want you to think about, you have the x minus 5 over here, okay? How do I actually get rid of the fraction? We already know that if I multiply the top and bottom of any fractions, for example, 2 over 3, if I multiply the top by 2, multiply the bottom by 2, it will be 4 over 6. Nothing changes. It'll still be 2 over 3, right? So with that being said, I see that I have lots of fraction happening over here. I don't really like it. So what I want to do, I want to multiply the top part by x minus 5, while I also multiply the bottom part by x minus 5 as well. So if I do that, then the top part will become x minus 5 minus 2. Okay, so the bottom part will become x minus 5 plus 3. So then you will have x minus 7 and x minus 2. So that will be your answer for this question. Pretty straightforward, right? So page number 78. Again, this is the summary for everything. I'm just going to talk about one of the questions. Let's talk about question number 3, actually. Okay, so question number 3, we have quadratic functions on both sides, right? So in this case, I kind of need to reduce it to make sure that my life is getting a little bit easier. So on the top, the 12a squared minus 6a can be rewritten as 6a times 2a minus 1. All right, and in the bottom part, when you factorize it, you will get 2a plus 1, a minus 1. Okay, in order for you to factorize it, I'm not going to go into too much details because, well, come on, you guys already been through all the factorization. Should be quite easy for you. If you still are having some difficulty, please refer back to the page 51 to 60. So next part, the 4a squared minus 1. Think about the 4a squared as 2a times 2a. Okay, so then you have 2a plus 1. This is the difference of square formula, and 2a minus 1. On the bottom, you have 6a. You have 2a squared plus 3a minus 2 because you have the 2 to the 8 factor of 3. So that's why you want to take out the 6, you want to take out the 8. So once that's done, I can reduce things across board. I can do the 2a minus, oh, actually, you know what? I can factorize this a little bit more. So actually, instead of writing it down like that, I'm going to factorize this a little bit more. I can do 2a minus 1 and then a plus 2 instead of the 2a squared plus 3a minus 2. Okay, so I can reduce across boards. I can do 2a plus 1. I can do 2a plus 1 over here. And then I can do the 6a. I can do the 6a over here and 2a minus 1. 2a minus 1 again. Anything else can reduce? Not really. So then on the top will be 2a minus 1. On the bottom, I'll have a minus 1 that coming from here times a plus 2 that comes from here. Okay. All right. So this is the questions on page 70. Let's see if there's anything else we want to talk about. 70b should be pretty straightforward. These are the same idea with these guys. Okay, so I'm going to jump directly into page 71. So irrational numbers. All right, so irrational numbers, again, back in level I, we kind of touch base on the irrational numbers. In this chapter, however, it gets a little bit complicated, a little bit sophisticated. But anyway, we're going to go through the examples first to see if we can recall some of the rules that we want to apply. So first of all, let's take an example. We have the square root 3 times 2 root 6 plus root 3. Okay, so in this case over here, we're multiplying back in. So the root 3 times the 2 root 6, again, you cannot use the 3 directly multiply the 2. You have to multiply within the radical signs, which means that the 3 times 6 will be 18. And then the root 3 times root 3. So any radical number, if it's the same base, which is in this case is 3, you will be getting the base itself without the radical sign. So again, let's say if I have root 7 times root 7, the answer is 7. Root 8 times root 8, the answer is 8, so on and so forth. Okay, so this is rule number 1 for us. All right, so this is quite simple. How do we get 6 root 2? Again, inside the 18, the 18 can be split into 2 times 9, and the 9 is actually a perfect square. So then this will be 2 times 3 instead, right? So if it's under the radical, it will be root 2 times root 9. And then that root 9 will be 3. So then you will have 3 root 2. That's how you get the 6 root 2. And you might be asking, Tony, where does the 6 come from? Don't forget about the 2 before that. You have to multiply the 2 with the 3. That's how you get the 6 root 3. Okay? Root 2. All right. With that being said, let's try question number 5 just as our practice. Question number 5, let's see if I see anything that I can multiply directly. If not, let's do this. So we're going to use the first number multiplied by that. So those will be 3 times 2. We already know that root 2 times root 2 will be 2. So those will be 6. Good. Now, that's 3 root 2 times negative 2 root 3. So this will be minus 6 root 6. Perfect. Then root 3 times root 2, root 6. And then minus root 3 times root 3 is 3, so minus 2 times 3, which is 6 as well. So I have the 6, and this is negative 6 root 6. This is plus root 6. So imagine this as negative 6 root 6 plus 1 root 6. The reason why I added 1 over here is just to help you guys understand, okay, root 6 is basically 1 over root 6. So in this case, the negative 6 plus 1 will be negative 5, so this will be negative 5 root 6. So that's the answer for this question here. Okay, so 71b, and we are using some rules that we have to refer to. So again, when you guys are doing questions like this, you have to understand difference of square and also complete square. So the rule over here that we adapt, right? It's basically x plus y to the power of 2 and also x minus y to the power of 2. This one will be x squared plus 2xy plus y squared. And this one be x squared minus 2xy plus y squared. So know this rule by heart, okay? So we're gonna use this as a reference. We're gonna try question number 7 and question number 10. So for question number 7 over here, you will know that it's gonna be this guys to the power of 2. So root 6 to the power of 2 minus 2 times root 6 times root 3 and plus root 3 to the power of 2. Okay, so this will be 6 minus whatever that is, 2 root 18. Remember that we have to simplify that, and plus 3. So this will be 9 minus 2 root 18. And the 18 we already know is 2 and 9, right? So we take the 3 out. So this will be 9 minus 6 root 2. And that will be my answer for question number 7. For question number 10, again, this guy to the power of 2 and this guy to the power of 2. I'll put it. So power of 2 and also 3 root 2 power of 2. I'm going to put it over here. And then in between is basically 2 times whatever this is and whatever this is. Okay? So after that being said, the 2 root 6 would be, how do we calculate 2 root 6 to the power of 2? First of all, 2 to the power of 2 is 4 and root 6 to the power of 2 is 6. So 4 times 6 is 24. So it's going to be 24, and on the bottom, like at the back, is plus 18, right? So this is 18. So 9 times 2 is 18, okay? And then in between is negative 12 times negative 12 times root 12. So I can combine them together. So this will be 42 minus 12 root 12. And root 12 is basically 4 times 3. I can take this out, so, right? So this will be 2 times root 3. And with the 12 over here, it will be 24 root 3. So 42 minus 24 root 3 will be answer for question number 10. So this summarized pages from 68 all the way to 71. If you guys have any question, please feel free to let me know.